Recording. Okay, this is our heading, sum of first n terms of an AP. This is kind of the last topic in this chapter, but it has like a few formulae, few different ways of approaching and some interesting results there, which will bring us to the last exercise. But yeah, I want to write this as the heading. And before we go and go to find uh, the sum of first n terms of an AP. I'm going to share with you a story. Okay, this is a story of a mathematician called Gauss, Gauss. Okay, he's one very famous mathematician. This guy was asked. I'm not an excellent storyteller, Dilruba, but I'm just going to go ahead and tell you. Okay, now this guy was asked to asked a question of what is the sum of the first 100 natural numbers. Okay, first 100 numbers, that time like mostly natural numbers. So 1 plus 2 plus 3 plus 4 plus dot 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 plus 99 plus 100. Okay, this sum he was asked. Yeah. Now he gave the answer immediately. Okay, he gave the answer immediately within seconds or within a very quick time, that the sum of first 100 natural numbers is equal to 5050. Okay, this was his answer. Now I'm going to give you guys to see if there is someone in the class who might be able to crack how could he have done this addition so quickly. Okay, so I'm going to leave. I do not want you to open your books. Okay, I do not want you to search it on Google. I want you to think and see if you have a shot at understanding how can a person add this much so quickly. Is there some way it can be done quickly? I'm going to leave the question here. Okay, then we'll come to how to do it, but I'm going to give you guys a couple of minutes time to think about this. Go ahead. Riza, have you already heard this?
No, sir.
Have you seen the derivation of sum of n terms of an AP?
Yes, sir.
So we'll hold it off. Yeah. AN is equal to 100. Okay, MG, AN is equal to 100, but Dilruba, that is a very, very funny answer. Dilruba has a very interesting, funny answer, but unfortunately, that's not correct, Dilruba. But yeah, it's very funny. How do you know that, Manisha? Then
Sir, I know, sir, like 99 plus 1, 98 plus 2, you'll get hundreds of everything, and only 50 will be remaining, and that will become 5000.
you have been exposed to this idea, right? I think by Sizer, right?
No, sir.
No. Okay,
No.
but this is good. This is a good observation, Manisha. So what are you thinking? So I am getting very funny responses from Mansa and Dilruba, who are saying, sir, hundreds half is 50, so 50-50, or 50 plus 50 is hundreds, so 50 5050. So yeah, it is funny. Yes, Nishchay, I remember I was a part of that class probably. But Manisha, nonetheless, can you just think out loud what you just said? Like once again, that's a very important thing there, and whether you remember it or there is your brain thinking right now, it's beautiful, and I want to hear that out.
Sir,
What is
like,
okay.
uh, I'm just looking how to find like hundreds or thousands. There are lot of digits, no, sir. Like, I'm trying to make them 100, like with zeros.
No, just
And
before this, what did you say, Manisha? Is it connected to that?
sir, 99 plus 1,
Okay, you're
98.
saying 99 plus 1, that is equal to 100. Okay.
Yes,
Then
sir.
you're saying 98 plus 2 is also equal to 100.
Yes, sir.
Is that what you're saying? Okay.
Like that, there will be 50 numbers, 50 hundreds.
There'll be 50 hundreds. Let's see. Okay, Manisha. So I'm going to take your thread of thought and going to do it. 1, 2, 3, 4, 5. ऐसे करके लिखते हैं. Somewhere it will be 48, 49, 50, 51, 52, and dot dot dot. Let's write 95, 96, 97, 98, 99, 100. Okay, tell me, Manisha. Now let's do it together. Tell me, Manisha, what is your thought here? Yeah.
Sir, 99 plus 1.
So you're taking 99 plus 1. You're writing that as 100. Okay.
Then 98 plus 2.
98 plus 2 is also 100. Okay.
So like that will continue till 49 plus 49.
49 plus 51, right? That's also
Yes,
100. Okay, so like that it will continue and you will get again plus 100. This will be how many times, Manisha? How many
sir,
times do you
50
think this will
times.
be? Huh?
50, 50 times.
Are you sure it will be 50? Because I'm a little doubtful of that.
Sir, 500.
Just think about it. This fully, sorry, 1 second. Sorry, this fully from here to, array yaar, what's going on with my,
Sir, 50 times itself.
this fully is 100. Okay. Have you
Yes,
taken exactly half of that? Or have you
sir,
missed some, have you left something out?
yes, sir, 50 and 100 we have left, sir.
You have left two terms out, right? That is 50 and 100.
Yes, sir. If we take even that 100, we will get 50, 100, sir.
Okay, even okay, nice. If so, till here, till about the numbers which we have circled, 97 plus 3, 4 plus 96, 5 plus 95, like that we can reach till here, right? 49 plus 51,
Yes,
right?
sir.
So that much, how many hundreds are there? How many such pairs are
49,
there?
49.
49 pairs, right? Good enough,
Yes,
right? So there are 49 pairs like this. Okay. And then you have what is extra here?
150.
The extra part is this 50 and this 100. So I'm going to write that just like this, 50 plus 100. It gives you how much? So 49 times you have 100. So this is how much, Manisha?
4,900.
This will give you 4,900 because there are 49 such pairs formed from here and here. 1 plus 99, 2 plus 98, 3 plus 97. Like that you reached, from there you reached till 4951. Okay. How did you decide 49 pairs are formed? Because 1 to 49, everything has a mirror part in 51 to 99. Okay. Good, Manisha. Yeah. This will give you 4,900 plus 50 plus 100, basically 5,000 plus 50, that's equal to 5,050. Very good, Manisha, and I really appreciate you being able to decode this on the screen with us. I'm going to give you 20 points again, and not 20, I'm going to give you 10 point. I don't know, I think you should get more than 10. I'm going to give you 15 points. Yeah, Manisha, really nice. Now there is something like, I'm going to use a similar logic, but I'm going to do it in a way, in a slightly different way. Okay. I'm going to use a similar logic, just going to use it in a slightly different way. Okay, same exact thing what Manisha did, but how I'm going to do it, I'm going to show that to you. Okay, actually, this is how Gauss also did it. Probably, I don't know, he might have used Manisha's method or what I'm doing here. Manisha, I'm just going to give you 20. I think 15 is also, it's a beautiful, like, that you have either remembered it or from Sizer class, or have been able to think about this right now. Wonderful, yeah. But I'm going to just think about it here right now. Okay, so I'm going to write 1 plus 2 plus 3 plus 4 plus dot 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 plus 96 plus 97 plus 98 plus 99 plus 100. Okay. Now what I'm going to do, Manish, I'm just going to write the same AP, same set of numbers in the reverse order. Okay. I'm going to write 100 plus 99 plus 98 plus 97 plus and so on. And I have plus 1 here, plus 2 here, plus 3 here, plus 4 here, plus 5 here. Okay. The sum, let it be called S. Okay. So S will be both ways. I can find addition. No, addition is commutative. So I reverse the order also, it does not change, right? Manisha, we good?
Yes, sir.
Yeah. Deepak, Dikshit, you're raising your hand. You have some doubt?
Sir, actually, even I have found a way and I'm getting 5050 only. Sir.
Okay. All right, Dikshit, you want to share that?
Sir, when I looked at the sum of first 10 natural numbers, sir, which is 50, and then when I saw the next 10 natural numbers, the sum of the next 10 natural numbers, sir, which is from 11 to 20, I'm finding it 100 plus 55. Similarly, when I take from 21 to 30, it is 100 plus whatever it was from 11 to 20. So I'm getting 55 plus 155 plus 255 plus 355. So when I do that, I'm getting 5050.
Nice, Dikshit. I'm going to give you 15 points here. The reason being that it's taking a lot more time, but very well thought, Dikshit. Okay. I really appreciate your thinking here. And I really appreciate how you stuck with the problem to try to find a trick here. Okay. And like this, there will be a lot of tricks. Dikshit, do you know why it is 100 plus 55 the second time you do it? Like 1 to 10 is 55 when you add. 11 to 10, 11 to 20, why is it 155? Do you know? Why is it 55 plus 100? Can you tell?
Every one number we are adding plus 10, sir. When we
Perfect, perfect. So each number is like 1 plus 10. Then it is 2 plus 10. To get 11, it is this. To get 12, it is this. Like that, there are totally 10 terms. So each 10 terms, you have added 10, 10, 10. So it's 100. Very good, Dikshit. Wonderful, yeah. Perfect. Good thinking, Dikshit. Okay. I love the way you have thought about it, stayed with it. It's okay if others have not followed Dikshit's method, but yeah, you can check with him later. Just in the interest of time, I'm moving ahead, Dikshit. Very well done. And I really appreciate your sticking with the problem. Yeah, just it's a little longer than Manisha's method and it takes more effort to calculate because all that 55, 155, 255, all that you have to add. So that's why I'm just reserving 5 points. Yeah, but it's not like it's lovely thinking. Okay, no doubt about that. Yeah. So here we are at S plus S. Okay. Now here, now see what Gauss did. Okay, he wrote the sum like this first, and then because addition is commutative, he just changed the order and wrote it. Okay. Now I want you to think about this. What will happen when we add equations 1 and 2? Okay. It's basically S plus S, that is 2S, right? On the left hand side. On the right hand side, what is happening? I want you to observe very carefully. Okay. This, if I add, I will get 101. Let me write it in the white pen only. 101. These two, if I add, I will get it. I will get again 101. These two, if I add, I will again get 101. Okay. These two, if I add, I will again get 101. Okay. Now each term, if I add with its mirror term, I'm just using like a normal English thing, like from the end, what is first? Okay. This is first from beginning, first from end. When I'm adding that, I'm getting 101. Second from beginning, second from end. When I'm adding that, I'm again getting 101. third from beginning, third from end. When I'm adding that, I'm again getting 101. Like this, if I continue, if you see here also 96th from beginning, 96th from end. If I add both of them, I will again get 101. 97th from beginning, 97th from end, I will again get 101. I will again get 101. I'll again get 101. I'll again get 101. Second from beginning, second from end, or it is 99 from beginning, 99 from end. Okay. Last from beginning, last from end. I'm again getting 101. Now my question is, how many times am I getting 101 here? Anyone? How many times am I getting 101 here? MG is saying 50 times. Let's see. MG, you are not correct. MG. Asgar, you raise your hands? No. Okay, I want everyone to think about it and tell me privately in the chat box how many times. Manisha, I know you might have cracked it. How many times? Yes, Deepak, you are right. Hey, everyone you told Deepak privately. Dilruba, Tulsi. Yes, it is 100 times. Okay. MG, you are getting this. MG, it's not 50 times because I have written everything from 1 to 100 in the first time also. I have written everything from 1 to 100 in the second time also. So when I'm adding this, it is getting repeated. Yeah, one is here also, one is here also. Basically, like this is giving me 101. 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 Like that 4, 5, 6, 7, continue till 96, 98, 99, and everywhere I'm getting 101. You're getting this, MG? Why it is 100 terms and not 100 times you are getting 101 and not 50 times? MG, are you following this? Can you please confirm in the chat box? Yeah. Bindu, you got this? Okay, great. Now this is happening. So what is basically this is happening 100 times. So how can I write this right hand side? Can I simplify the right hand side? Can I write it in a simpler way? I am adding 101 again and again 100 times. What is the mathematical way of writing it? Thank you, Deepak. Perfect. So this is 101 into 100. Okay. Multiplication is nothing but repeated addition. So if because 5 plus 5 plus 5 plus 5 is basically 5 into 4. Just like that, 101 plus 101 plus 101 plus 101, 100 times is basically 101 into 100. Okay. Multiplication is repeated addition. Now that gives us, but I want you to observe very carefully. On the left hand side, I still have 2s. I have to find s only. Okay. I don't have to find 2s. I have to find s because s is the sum. Yeah, this sum of first 100 terms you have to find. I have got 2s now. So what I'm going to do, I'm just going to use linear equations here. I'm going to take 2 to the other side. So I have s is equal to 101 into 100 by 2. This cancels off 50. That's equal to 101 into 50. If you multiply this, you will get 50. Don't say like that, 5050. Okay. That's basically the process which the great mathematician Gauss, this is basically the process which the great mathematician Gauss used. It's very similar to the process which the great mathematician Manisha used in our class today. But I'm not going to like it's just this. There's the slight differences. Like here, I will be able to generalize this process into any AP, and that's what I'm going to do now. Okay. But before I go and generalize this for any AP, can I get a fist to 5 in the chat box, please, about how to find the sum of first 100 numbers? Yeah. Logically, okay, I have not yet got a formula, but logically, one was Manisha's method, one was Dikshit's method, and one was the famous mathematician Gauss's method. Yeah. If Gauss's method, I want you to give me a fist to 5 on Gauss's method. Okay, whether you have understood Obviously, you would have understood Manisha's method. Maybe you did or did not understand Dikshit's method. That's okay. But did you understand what's going on the board right now? I want to fist a 5 on that. Okay, simple, yeah. Dikshit, it's no, I wouldn't say a kharab mathematician. That Dikshit, sometimes a long method leads us to appreciate some really interesting things about numbers. Like you could appreciate how 11 to 20 is basically 100 plus 55, yeah. And 20 to 30 is basically 100 plus 155. That's something which your method allowed us for. Okay, and it's very, very beautiful to be able to see that, Dikshit, and to be able to appreciate that. So I'm not going to call you a kharab mathematician at all. Just you did a very good thing. Yeah, you were fantastic in that observation. What are you writing? MGD. MGD is equal. What are you saying? I don't know. MG. Okay. Shri Priya, can I get a response from you, Ma? Oh, Manisha, Gauss, and Dikshit. Okay, okay, cool. All right. So moving on. Yeah, now I'm going to generalize. Now, what we're going to do is we're going to generalize this method, okay, to any AP. Yeah, and it's going to be very simple, okay. I want you guys to like take this down also. Okay, this is beautiful. I want you guys to take this down also. I'll give you guys 1 more minute if you need. 1 more minute to take things down if you need till here. Okay, this is Gauss's method. Gauss's method of adding first 100 natural numbers. Okay, this is Gauss's method of adding first 100 natural numbers. Dinesh, you have typed something in the chat which I saw just now. Sorry, I'm not paying attention to the WhatsApp chat enough. Yeah. One second, guys. I'm getting a call. Yeah. Guys, just hold on for 1 second. I'm on an emergency call. Yeah, just 1 second. Dinesh and Abhi, can you hear me now?
Yeah, sir, I can hear.
Okay. So, sorry for the disturbance, guys. Got a personal call. Okay, so we are good here. Shall I move ahead now? Can I, people on the on Zoom, can you give me a thumbs up if you're good? to move ahead. Shri Priya, should I move ahead? Okay, moving on, guys. Now I'm going to use the same. We're going to use the same method, okay, to find the sum of n terms. Thank you, Shri Priya. Sum of n terms of an AP. Okay. Still now, what we did was we took a particular very simple common AP, that is numbers from 1 to 100. Now what we want to do, we are going to take a general thing, okay, the general form of an AP, same thing, okay, general form of an AP, okay. Generally an AP is like this, right? A plus D, A plus 2D plus not plus, sorry, dot. It will go on. What will the last term be? What will the last term be? Anyone? Mansa, can you tell me what the last term will be?
So it will be A plus 3D.
Next term, last term.
ND, sir.
ND will, okay, if I have, okay, A nth term will be how much?
Sir, A nth term will be A n plus D, sir.
Come on,
AN?
Mansa. What is AN का formula क्या है, Mansa?
Sir, AN.
What is the formula for AN? What will the nth term be? Mansa, looks like you're not in class, or looks like you're just a little bit lost here. This A plus n minus 1D, you had only derived this formula, Mansa.
Yes,
I was upset about it. Okay, so this is how my AP looks. Okay, this is my general form of an AP. The next term after this is A plus 3D. So basically, every step, whatever it is, A4 it is then 4 minus 1D. A10 it is then 10 minus 9, 10 minus 90, that's 9D, 10 minus 1D. It's like AN is A plus n minus 1D. Mansa, is this okay with you?
Yes, sir.
Where is your mind?
Sir, I was a bit lost.
So now what you're going to do, we are going to like to find the sum of this AP, okay? Let the sum of first n terms be S, okay? Let the sum of first n terms be Sn, okay? Let's call it, let me see what they call it in the book. Okay, they are calling it S, let us also call S, okay? Now, actually, let's call S only. Now, S is equal to what? It is A plus D plus A plus 2D plus dot. Can I continue like this? Last second term will be what? A plus n minus 2D. Yeah, Mansa?
Yes.
Last term will be A plus n minus 1D. Is this okay? Is it okay with everyone? This is the AN, this is just before. So if it is A100, this will be A99. Yeah. Is this okay with everyone? Guys, what I have written sum of n minus 1 terms as, sum of n terms as. Specify in the chat box, please. Basically, I'm adding each term, yeah. So first term plus second term plus third term and so on till the last second term, last term. Okay. If you want to write the last third term, you can write that also. It will be just here. It will be A plus n minus 3D. Okay. Last third term. If you want to write. Okay. Everyone following this so far? I'm going to use the same method and I'm going to write S is also equal to, I'm going to write it ulta, okay, just like we did in the Gauss's method, okay, just like we did above. I'm going to write this ulta now. Excuse me. So I have A plus n minus 1D, okay. Second, I will write A plus n minus 2D. Third, I will write A plus n minus 3D, okay, plus so on and so forth. Last will be A, last second will be A plus D. Everyone okay with this? Can I get a fistify in the chat box about my second equation here? Same sum, I'm just using commutative property and I'm just writing this thing first, okay? And then this thing second, and then so forth, and then this thing last second, and then this thing last, yeah? That's what I'm doing here. Abhi and Dinesh, are you following this? Okay, good. So now I'm going to use the same process which Gauss used. I'm going to add these two equations. So 1 plus 2, let's write this as equation 1 plus equation 2, 1 plus 2. Now, important to note, I'm going to add this with this, okay? First term with last term, last second term with first second term, starting say third term with starting last say third term, and so on and so forth till I reach last second term plus second term, last term plus first term. Okay, like this I'm going to add, and I'm going to get the same answer in all these cases. Okay, I'm going to get the same answer as all these cases. Basically, what I'm going to get is a plus n minus 1d. Okay, if you see, this is what I'm going to get in every case. Notice what's happening in the second one. Okay, this is the first. This is first one plus first one. Okay, this is that. Okay, let's do second one plus second one. Okay, what are you getting? You are going to get a plus d plus nd minus 2d. Correct. I'm opening the second wala ka bracket. Okay, nd minus 2d plus d minus 2d will give me how much? It will give me a plus nd minus single d. Everyone okay so far? That is basically same as a plus n minus 1d. You see this? So when I add this also, I am getting this only. Okay. Now I'll just show one more example. I'll add this one and this one. Okay. Watch what I'm doing. Okay. So I'll get a plus 2d plus a plus n minus 3d. Okay. I'm adding the orange ones, these two. Yeah. So what's happening there? I'm just going to open this. Okay. Now I'm going to write equal to here. I have a plus 2d plus a plus nd minus 3d. Correct? It's basically what? A plus a, and I will add together, it can be 2a obviously, plus nd I will leave as it is, minus 3d plus 2d. Sorry, minus 3d plus 2d is how much? Minus 1d, right? That's minus d. That's a plus d common, n minus 1 into d. Dilruba, did you follow this? Dilruba? Are you seeing, Dilruba, that I'm getting the same sum in this red when I'm doing these two addition, when I'm doing these two addition, when I'm doing these two addition, and I'll get the same sum here also, here also. You can add and check. Yeah. But I'm going to just simplify that, crunch that. I'm not going to write the whole thing here. Okay. You can write it in the corner and keep for yourself. So what is the sum? What is this sum basically? This is a plus a is 2a, right? The sum is 2a plus n minus 1 into d. Okay. So this first time I'm getting 2a plus n minus 1 into d. Then again I'm getting 2a plus n minus 1 into d. This is second one. Okay. Then again third one I'm getting 2a plus n minus 1 into d. Yeah. And so on, it continues till the last term. Okay, till the last, this two also if I add, this two also if I add, everywhere I'll get the same thing. 2a plus n minus 1 into d. Okay, let's put this in a square bracket. Yeah, let's put this in a square bracket. Let me rub this off. Everyone clear of how I am getting 2a plus n minus 1d? As many times as I add this plus this is giving me this. Yeah, as many times as I add, each one of these additions is giving me this. Okay. Dilruba, ye clear hai Dilruba for you?
Yes. Sir.
Cool. Now what's going on, guys? How many times am I adding? How many times is this happening? Can someone tell me? Totally, how many times have we done this? Anyone? The question is open. Riza, you're correct. MG, you're correct. Manisha, you're correct. Let's see. Deepak, are you sure about that? Deepak, Nishay, you are correct. G, you are not correct. Very good, Dilruba. कितने टाइम में nth टाइम नहीं बोलेंगे, n टाइम्स बोलेंगे, ठीक है? So this time you added first. So let's look at this, okay? Here you added one time. Here you added second time. Here you added third time, and so on. Here you added n minus 1 time, and here you added n times. Correct? So totally you have added n times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till n. Okay? That's the number of times I am doing the addition. So this process is happening n times. And I'm going to use the same thing. Multiplication is nothing. Repeatedly you are adding the same number. That same number is very big here. Okay. This big thing you are adding again and again to yourself, to itself. That's correct. But basically you are adding this n times. So n into 2a plus n minus 1 into d. Okay. 2s is equal to this. So that gives us the formula for sum of n terms of NAP. Not 100th time, Bindu, not 100th time. I did not say n is 100, no. I'm taking general, no. This can be a 100, but this can be a 20 also. This can be a 5 also. I don't know how many n's I am taking. What is n? I don't know. Bindu, are you getting this? So n times I'm adding. Bindu, are we good?
Yes, sir.
Okay. So that gives us n into that number, that is 2a plus n minus 1d. So that is equal, that means s is equal to, I have to find s, I don't have to find 2s. So s is equal to n by 2 into 2a plus n minus 1 into d. This is the formula for sum of n terms of an AP. Okay. So the way of writing it is sum of n terms of an AP, we will write it as S subscript n. Okay, capital S subscript n is equal to n by 2 into 2a plus n minus 1 into d. Yeah, and I wanted to write this, put this in a box. This is the one of the most important formulas of this chapter. Actually, the only little formula in this chapter. This is the, now we're going to see the sum in a few more ways, but that's the broadly the formula. Yeah, take this down, guys. I'll give you 2 minutes. Yeah. Riza will go there. Yeah, give me a minute. This is for any n terms of an AP. Okay, let everyone take this down and we'll go to the extension of this formula. There's another way of looking at this formula. You have a minute to take things down, guys. Try to take things down in a way you understand. Okay, take 2 minutes to take things down. Okay, please make sure you understand how the sum is coming and all of that. This derivation can be asked. Yeah, so take things down in a way you understand what's happening. I'll be back in a minute. Take things down. Dilru, I have shared a screenshot on WhatsApp. Please type done if you're done taking things down. Okay, we're going to move ahead now. Now I wanted to watch closely, like there's something special about this formula, okay, and I wanted to watch what we are doing essentially, okay, how we are getting this particular thing, okay, this particular thing, how we are getting this, you know already, and you know how to came in, but this particular thing, how we are getting, okay. Now what have you added to get this, guys? Can anyone tell this to me other than Riza and Nishchay? Probably what are the two things that you're adding to get this particular term? Just see this, what I've underlined, okay, the red things which I've done, okay. So you have, which two things are you adding to finally get this thing? Yes, MG, you're absolutely right. A plus AN, okay. First term plus the nth term you're adding, yeah. So basically I can break this down to write it like A plus n minus 1 D, yeah. 2A I'm breaking into A and A, yeah. This is A only, and this is AN. So our formula can also be written. This is another way of writing the same formula. Suppose you are not given A and D, you can write the formula like this also, okay. I'm just going to write that down again. So Sn is equal to n by 2. Everything else remains same. Just write A plus n minus 1 into D, okay. And this thing I want you to mark this as AN, yeah, it is AN. So that gives us Sn is equal to n by 2 into A plus AN, which means if you're given the first term and the 10th term, you don't have to know the common difference to find every time. Okay. And you're asked to find the sum of 10 terms, you can find it just like that. So put this in a box. Okay. Now suppose it is a finite AP. Okay. Suppose it is a finite AP. Okay. If there are only n terms, if it is a finite AP which has only n terms, okay, n terms in the AP, then basically your nth term is the last term, right? So your Sn can also be written as n by 2. So you can, no, don't write Sn here. You write it as S is equal to n by 2 into A plus L. This is another way of writing the same formula. Take all of these three down. Okay, take these two new things also down, and we will. This is if there are only. This is important. Okay, when this is the condition. So when this is the condition, then an is equal to L. So maybe in this box you put all of this together. Maybe in this box you put all of this together. Yeah. These two boxes extra in your notebook, please. And then we will do a few questions. First term plus nth term, correct? So what we're going to do now is we're going to do a few questions on this thing. Okay, some simple questions, and we're going to have a simple homework tomorrow. My plan was to finish this and then take the test tomorrow, but again, things have not gone according to plan a little bit. So we'll see when to write the test. We'll think about it. Type done if you're done, guys. Okay, moving ahead, yeah. So let's do this. Okay, the first question. We're going to do the examples as usual. Okay, just to like keep like examples to cover a lot of basic types of sums and basic type of questions, and also like some really tough ones which the exercise has. So we're going to start with example 11. It's a very simple thing. Find the sum of the first 22 terms of the AP 8, 3, -2, dot, dot, dot. Okay, it's a very simple question. They have given you an AP. They're asking you to find the sum of the first 22 terms. Okay, sum, your first formula that should come to your mind is sum of n terms is equal to n by 2 into 2a plus n minus 1 into d. Okay. You write down this formula first. Okay, I'm doing this question on the board. Okay, you write down this formula first. Now your mind should think, what are the different things in this formula? Sn, you have to find S22. So don't worry. Your n is equal to 22 because they're asking first 22 terms ka addition you have to do. Okay, so n is 22. A is also given. A is 8. D is also given. D is basically to find 3 minus 8, that's equal to minus 5. Yeah. So far, so good, everyone? Everyone good with this? One second, Dilruba. I'll put it now. Okay. So this is n is equal to 22, a is equal to 8, d is equal to minus 5. Now, in this formula, you know n, you know a, you know n, you know d. Can you find the answer? Go ahead and do it. Sum of 22 terms, S22, I'll write it like that, is equal to 22 by 2 into 2 into a, that's 2 into 8, plus n minus 1, that's 22 minus 1 into d, that's minus 5. Okay. Solve this and tell me the answer. You guys have 1 minute. The answer finally that you get should be minus 979. If you're not getting this, tell me, I'll do it. Okay. You have 1 minute to do this. If you're not getting the answer, tell me, I'll do the calculation also. First check if you're not getting, okay. Thank you, Bindu, for confirming that you've got the answer. Waiting for others. Please calculate and tell that you've got the answer. Thank you, Mansa. Thank you, Shri Priya. Thank you, Manisha. Thank you, Tulsi. Thank you, Deepak, MG, NG. Okay, everyone has got it. So I'm going to move ahead now. Okay, the next question. The next question is also a little interesting. So this was a very simple question, the one which we did right now. We were basically just putting things in a formula and solving it. The only thing is you should know which formula to use, and there are only going to be 2-3 formulas. So even if you think of all of that, only one of them, maybe one or more of them will work. Anyone which works, you should use that. Okay. So example 12, if the sum of first 14 terms of an AP is 1050 and its first term is 10. Find the 20th term. I'm going to quickly demonstrate this, okay? Just in the interest of time, I'm going to quickly demonstrate it so that we have a good chunk of homework. Okay. Now, guys, saying sum of first 14 terms. So you just write down what's given, right? Sum of first 14 terms is 1050. Okay. All right. Sum of first 14 terms is 1050. It's also saying the first term is 10. Okay, cool. Find the 20th term. So 20th term means what do you need? What do you need to find A20? Anyone? What all do you need to find A20? Can someone tell me what all do you need to find the 20th term? Come on, Manisha, I don't want you to answer. It's a very simple question. Someone else? Bindu, Shripriya, Deepak, Dikshit, Dilruba, Mansa. Someone tell me, guys. What do you need to find A20? What all do you need? Just tell me the formula. Yes, Bindu?
Sir, A plus n minus 1
How much will it be?
bracket
20 is n, no? So how much will it be? A plus? Bindu?
A plus, yes sir.
This is 20. Then
A
n
plus
minus 1 will be how
20
much?
minus 20 minus 1 sir.
Yes, to
19.
19D. You don't have to write this every time n minus 1 there, okay? If you know this, you can just write A plus 19D, okay? General form of an AP permits us to write that. So what all do you need to do this form, Bindu? What all do you need? What all information do you need to find A20? Bindu?
Yes sir. So we need to know the formula.
Is that enough? If you know the formula, can I find A20 now? Next step. What do I need to find the value of the formula?
Sir, we need to know the first term, common difference, and
That's all, right? What else? There is no other variable in this formula, right? So I need to find A and I need to find D. If I know both of them, I will be able to find A20. Are we good, Bindu?
yes sir.
Okay. 21. This you already know. N you already know. Now A also I already know. A is 10 given. So I only need to find D. Okay. I only need to find D. That's the process that I'm going to use. Okay. So basically here I know that A20 is equal to A plus 19D. Okay. Now D is what you don't know. So D you have to find. For finding D, I have some information. I have S14, which means S14 is also equal to what, Bindu? Can I write it as n by 2 into, basically let's write Sn is equal to n by 2 into 2a plus n minus 1d. Okay. Now in this formula, you know what n is. Suppose 14th wala I'm taking first situation. Okay. 14th wala n is 14. You know that. N you know. A also you know. 10 it is given. Only D will remain. You can solve this. Okay. So what I'm doing, I'm writing for n equal to 14. You know S14 is how much? 1050. Right. Let's write S14 first. Okay. Let's write S14 is equal to, it is sum of first 14 terms is equal to 14 by 2 into 2 into A plus 14 minus 1, that is 13. You can do that mentally also. You can write 14 minus 1 also into D. Now, in this also there are two unknowns, but 1050 is known. So in place of S14, you can write 1050 is equal to 14 by 2 is 7, 20 plus 13D. Bindu, can you find D from here?
Yes sir.
Can you find D from here? Once we find D, can we find A20? Once we find D, we can find A20, right? So I'm going to
Yes,
just, I'm just going to do divide by 7 on both sides. So 1050 by 7 is equal to 7 by 7, 20 plus 13d. Why I'm dividing by 7 is because this is divisible by 7. So this is going to give us, how much does 105 go? 15, no? 135, 5, yeah, 150. So 150 is equal to, this and this gets cancelled. So 1 is remaining, 1 into 20 plus 13d is 20 plus 13d. So 20 comes to the left side. So 150 minus 20 is equal to 13d. Or 130 is equal to 13d. D is equal to 30, 130 by 13, that's equal to 10. Okay. Now A20, can I find? A20 is A plus 19D. A is how much? A is 10. D is also 10. That's equal to 10 plus 190. That's equal to 200. A20 is equal to 200. Bindu, is this okay?
Yes, sir.
Yeah. Basically, what I did was I wrote down what I knew from the question. I wrote down what is given in the question. These two parts were given. I wrote down what I need to find. And in that formula, in what I need to find, I thought, okay, to find what I need to find, I need A and D. I already have A, I need to find D. Okay, is there some way in which I can find D? Yes, the way is by using sum of n terms formula. I wrote that formula down. I had the value for everything except for D, which became a linear equation, and I solved that. That's the second question, guys. And that brings us to the end of this class. I was hoping to cover some more, but it's okay. We will take some time tomorrow also to cover. Okay, let's write down the homework because we will have some homework now. Okay, sorry, Dinesh and Abhi. I've shared the screenshot. Just take down the homework and then you guys can drop off. Okay. So the homework is, guys, screenshot is shared. Okay. Homework is exercise 1.3 in your textbook, exercise 5.3 in the NCERT textbook. You have to do question number 1, main, first main, second main, third main also. Third main has like a total of 10 questions. And fourth main, fifth, let's try fifth main also. Sixth main also. Okay, let's try these two. These two we might discuss, but these 4 pakka. Okay, all 4 of this should be pakka. Fifth and sixth is like something we might discuss, but you should be able to do nonetheless. Okay, so this is your homework. I'll send you a mail for this. You can drop off now. Thank you for staying back. Bye. Thank you for the class. Give me a fist to 5 on the class and then you can drop off.